Hello, this is G. Ramesh Kalyan, Assistant Professor, Department of Computer Science and Engineering, SNS College of Technology. The course name is 19 CST 302, Neural Networks and Deep Learning. The topic name is Rectified Linear Unit, ReLU. So, as a continuation of lecture series, in the previous video we saw about what is a vanishing gradient problem is and how to overcome using a ReLU, that is Rectified Linear Unit. So in this video we will be seeing about the rectified linear unit. So what is rectified linear unit and what are the process and what are the applications of it. So initially a rectified linear unit is widely used as an activation function in a neural networks. So it is simply a piecewise linear function that outputs the input directly if it is positive, and otherwise it outputs 0. That is, ReLU is activation function. So it is a simple piecewise linear function that outputs the input directly if it is a positive, otherwise 0. So if the input is a positive one, it has some outputs nearly to it, or else it just gives output at 0. So mathematically this rectified linear unit is defined as f of x is equal to max of 0 comma x. So where x is the input to the function. So this ReLU rectified linear unit has become popular mainly due to its simplicity and effective training of deep neural networks. So as we saw previously, the vanishing gradient problem. So what are the advantages of rectified linear unit? So the first one is sparsity. So rectified linear unit neurons can output 0, which means they can sparse, leading to more efficient models. Next one is non-linearity. So rectified linear unit introduces a non-linearity to the model, allowing it to learn complex patterns and relationships in the data. And next one is efficiency in training. So this efficiency is training is conceptually so rectified linear unit is simple as compared with the other thing, like other process. So it doesn't involve any complex mathematical operation, and which makes it faster in its work and more efficient as compared to the other activation functions. So what are the advantages of rectified linear unit? So first one, it avoids vanishing gradient problem. So this is exactly what we explained, or else what we saw in our previous video regarding the vanishing gradient problem. So as back propagate, that is from the output layer to the previous layer till the input, or not even to the input layer. When we output from the output, when we back propagate from the output layer to the previous one, um, actually the gradient becomes very smaller in size, which even vanishes at a certain point of time. So this is a vanishing gradient problem. So in order to avoid it, we are using this rectified linear unit, which helps mitigating the vanishing gradient problem encountered in deep networks during the process of training the deep neural networks. So as it doesn't saturate for positive input values, allowing for more effective backpropagation. However, rectified linear unit does have some drawbacks, such as so these are some of the limitations. That is the dying ReLU. The problem. So this is a problem in which the neurons can become inactive if they consistently output 0 for all the units during the training process. So this is one of the limitations. And second one is by using the variants like leaky rectified linear unit, the parameters of exponential linear unit ELU, which aim to elevate this, is treating the advantage of ReLU. So rectified linear unit. So we'll have a quick we'll see again. So rectified linear unit is activation function that is used in the neural network. So it is a simple linear function that like outputs a value if it is a positive input, or else 0 if it is a negative input, or else if it is a negative input. So mathematically this rectified linear unit is defined as f of x is equal to m of 0 comma x, where x is the input of to the function. So we saw the advantages, that is sparsity, non-linearity, efficiency in training. Then the advantages, so the main advantage of rectified linear unit is avoids vanishing rating problems, and drawbacks is the dying value, as neurons become inactive if they consistently output 0 for all the input during the training of neural networks. This is the rectified linear unit.